show you this one, which is a little more fundamentals, and then we'll get down to the cryptography. So I'm using my Mac here again. All right, so I can do interactive mode for this because I'm only using short little programs. And so here's an integer, simplest, most common data type. So I equals 1. Python is a loosely typed language like JavaScript. It guesses what you mean from context. So if you set I equals to 1, it determines it to be an integer and not a string or anything else. So you can print I and type of I to find out what type of variable it is. So it's 1 and its class is integer. And since it's an integer, you can add 1 to it and put that in J and you get another integer. So that makes sense. Now, bytes are not quite the same. If I define a byte, I use this B before a quote. So it's like a string, except I have a B, and I could put letters in there, or I can put \x binary hexadecimal values. So this is a byte with a value of 1. And if you print it, it shows up in the same format. That's a byte containing 1. And if I try to add 1 to it, I can't, because a byte is not an integer, and you can't add 1 to it. All right, so one way to convert a byte to an integer is to choose a specific byte in there with a sub 0, 1. Here I defined A to be a 1-character byte array with 1, and here I define the first element of it to be B, and that's going to turn out to be an integer. So this is something. The other thing I found confusing about Python 3 at first, there are these 3 variable types, strings, bytes, and integers, and you very often have to switch from one to the other to get the job done. So this is the 0th element of the A byte array is a integer, and you can add to that. So if you wanted to add 1 to a byte object, you could do it in a few stages here. And let me do it and then talk about it. All right. So here I define a byte array with a 1 in it, and call it A, and that's what it is. It's bytes with a 1. Then I define B to be the integer value of the first element, and that's 1. So I can add 1 to that, making it C. That's an integer of 2, and now I can create a new bytes object containing that integer, for which you use this parentheses square bracket format. And now I have created a byte object that is 1 higher than the original byte object I started with. So you have to do quite a lot of that in Python, flipping from one thing to another. And if you want to read or write to a file, that's important to know. We'll be using that to encrypt and decrypt an image pretty soon, for example. So let me make this program first I'll make an in file that contains hello. All right. And then I'll make, what is this? It looks like read. Okay, read.py. There are many ways to do this sort of thing, but this is the simplest one, and it reminds me to explain indentation in Python, which is, I was used to C as a programmer, where you begin any block of statements with a curly brace, and you have a curly brace ending it, and that is not how Python works. If you're going to have any command which refers to a block of commands after it, you end it with a colon, and then you indent the next line. And all future lines that are indented the same way are in the block, and when the indentation stops, you're no longer in the block. So there are 2 blocks here. This will open this file to read in binary and give it a handle of F, and everything below it is going to happen only while that file is open. And when I'm done having that file and done being indented, it will automatically close that file. So now I read 1 byte, and if the byte is not empty, which is what this says, then I print it and read the next byte. So this is another loop. This is a loop, a while loop, and the colon means it's expecting indented lines, and those lines are the indented, and that's the end of the while loop, and it's also the end of the with loop. So this will read this file, and it will print the contents of it byte by byte. So if I save that and run it with Python 3, read, there, it reads my hello file and prints it out byte by byte. Now, this one here is going to read it and write out a copy of it. So this is going to be write, I guess, write.py. All right, so it's going to open the in file for reading binary and then open the out file for writing binary as G. Now, for every byte, it's going to read a byte, and if the byte is not empty, it's going to print it, write it to the G file, and then read the next byte. So this will just copy a file byte by byte. So let's try that. All right, so it printed this stuff out. By the way, it was in bytes instead of printing it out as strings, the way it did up here. But anyway, it should have made a copy now. If I do ls-l, I've got the in file, and here's the out file. They're both 6 bytes long. And if I cat them, the in file contains hello, and the out file contains hello. So you can read a file byte by byte and print it out byte by byte, and you know how to manipulate bytes. So now you can do a few challenges. Here's a file, and you can download that thing and count the number of bytes that are equal to 8. That's the flag. And the next one, you have to add files. This is a simple way, by the way, to hide information. It's a simple extension of the Caesar cipher. The Caesar cipher is actually pretty good on bytes if you move it through whole bytes of 256. And this one here, you have 2 files, and to reconstruct the contents, you have to add them byte by byte. So this is a little bit like the one-time pad, where one of these would be the key and the other would be the ciphertext. You have to combine the bytes together. So one contains 40 and the other contains 1. The result would be 41. And adding these things together byte by byte will create the flag. And here's another one where adding these together will create an image, flag.ping, so it's a longer one. And neither of these will be a valid image file, but when you combine them byte by byte, they will turn into an image file, which you can then open and read the flag. So check that stuff out.